Here I am going to cover the topic which is normally covered in a full semester course. I am going to finish it in an hour or less than an hour. So this is going to give you some overview in case if you happen to decide to choose some course similar to this, you will have an idea of what is likely to see in this domain. And this is very relevant to IoT. So you should know this, whatever the high level information that I'm sharing, and it's not complete in any sense. So what I plan to do is to give you a flavor of what the WSN is, and then I'll give you some major characteristics of a sensor network. How is it different from normal computer networks, and why is it working in an IoT environment? And then we'll see a couple of architecture, which is just a high level architecture, and use cases. Okay. Now, I think this reference is not a right reference. Maybe I will remove this. Okay. Now, what is WSN? It's a collection of numerous networked low power microsensors for data acquisition over large areas. So we are interested in knowing what happens in a given area, maybe pretty large, and then sensors are literally dropped in this large area to collect information about what is happening there. So I'll tell you some use cases, scenarios where you can make sense out of this. But this is a collection of different sensors over a large area. And of course, they are all low power devices. And it's a large scale deployment is possible because of recent advancement in technologies in the hardware, sensor and wireless networking. Moreover, cost is also coming down drastically, that we can afford to buy a chip which is a multi-core chip for a few dollars is something which we could not even imagine 10 years back. Now, unlike traditional sensors, these microsensors have not only they sense the environment or find out the values around whatever value they are measuring, they are also part of the network. It's not a dumb sensor like a temperature sensor or a pressure sensor. These sensors are intelligent sensors which participate in the network. So they have sensing abilities. Maybe one or many sensing devices will be there, but they also participate in the networking, and they do some processing also. So they are intelligent low power computing devices which are called sensor nodes. That's why in yesterday's lecture I showed you some devices like this and then sensors also. So the sensors also participate in communication. Though we call them as sensor nodes, do not think that they are dumb sensing devices. They have capability to process the sensor readings as well as share it with the neighbors. At times even they respond to commands. Maybe they may measure some different quantities based on the command coming from the control center. So that means sensor nodes should have different sensors, of course, which takes care of sensing the environment. They need to have an embedded processor, of course, memory, and a low power radio for communication. As I mentioned, these devices cannot have a wired communication. They need to be wireless. So they have a low power radio and a tiny battery maybe. And of course, it is required. And then there may be energy harvesting capability that helps you in terms of charging the device so that the lifetime can be in terms of years or decades. Now, a typical sensor wireless sensor network will be a collection of sensors and a gateway. Sometimes it is called sink because all these devices sync the data into this device. So it's called not only a gateway to the network, it is also called a sink because they collect information from all the sensors. and then they pass it across. Now, how does the sensor node internally look like? A microcontroller with a transceiver. This is for changing the from one thing to another value. It could be meant for communication, and I added a communication channel also. We can use this also for the communication purpose. And then we have a sensors. Naturally, all the sensors give analog output. So we need an ADC to convert them into digital values and store it in the memory, and then pass it across through transceivers or communication channels that it has. Now, what are the major features? Of course, it has to be miniaturized, low cost, low power radio, autonomous ad hoc connectivity. They need to be connected to the sensor network automatically, and there is no human interaction involved. And what the WSN does, based on locally sensed parameters, a sensor network provides a global view of the monitored area. So collective data gives you an overview of what is happening in this given domain or area. It could be a field where you are measuring the humidity and other parameters of soil, or it could be in a fence across the nation where you are finding out if there are any intruders in the entering into the domain, or it could be a mountain area where you are measuring the pressures as well as any changes happening to avoid a recent happening like a landslide or a flash flood that happened in Uttarakhand. We could have avoided it if we had a wireless sensor network on places where the snow avalanche is possible. The avalanche could happen in those kind of domain. Then we could have avoided that such a huge loss. So I hope this gives you an overview of what individual sensor node has, and then what a particular network, which is a collection of different sensors, is meant for. What do they do, and how do they communicate back to the control center? So that's my idea of giving you a picture of this. Now, how do we deploy such a network? These sensors could be deployed permanently at a pre-specified locations in a given area, okay, which is accessible. That if the area is accessible, we can go there and then plant those sensors, which is a friendly environment, not a hostile environment. But in case the territory is unknown, maybe a border to our nation, like maybe into China or maybe into Pakistan, an unknown territory, if you want to plant some sensors, we may have to use some unmanned aerial vehicles or ground vehicles to just distribute the sensors there, and then maybe sync or other devices may be there on our side, then try to understand what is happening in the nearby areas. So the tactical surveillance in military applications could also possibly use this kind of sensor networks. It could be used for commercial as well as civilian use purposes. It could be for road traffic surveillance, or as I mentioned, in agricultural field, it could be used for different purposes, for watering the area or to find out the soil nature, and then what need to be done to improve the productivity of agriculture. All that can be done. Now, having learned about what is WSN or wireless sensor network, let us see the major 4 essential characteristics of this network. One is redundancy exploitation. Now, from the name you can make out that the WSN has huge number of a large area it covers, as well as it has many sensors in it. So we can exploit the redundancy because we have more sensors at our disposal because of the low cost and the production manufacturing productivity. We could afford to have many sensors in a wireless sensor network. So it's always a network which has got many sensors. So the sensors nodes are prone to failure because they are low cost and low power, and they are living in a hostile environment. They are prone to failure. So we need to have a redundancy built into the system. That's why we put more sensors than what is required. Even if some of them are out of shadow area, they fail, we still get a feel of what is happening in the area. So we need to place random placement. We do the nodes, sensor nodes on the harsh environment. They also expected to run out of energy because limited battery power is there. So we need to cater for nodes failing. So redundancy and device density, we put more sensors there. Because of that, we get a redundancy. We can explore, still we can exploit and make the network work, function without much of a problem. So it is expected to self-configure. Now, as I mentioned, the nodes can fail because of different reasons. The network protocol, what is being considered, they should be self-configurable. That means we cannot have a fixed path for reaching a sense. This is what sync is. Normally, as I mentioned, the devices communicate with the nearby nodes, and then the data gets flown to the sink. There is nothing like end-to-end communication here. It communicates to the nearby nodes, and then finally the data reaches the gateway. From there, maybe it will follow some normal computer networks protocol. Now, in this scenario, the nearby nodes, what the sensors are communicating, may die, and then they need to be in a position to configure it itself based on what happens around the system. So the protocol that we have in this kind of an area application, they are self-configurable, and that's why it's called ad hoc computing. So that is one thing. Redundancy, we exploit it based on what we choose to do, and then how we communicate from a sensor node to a sink so that the data gets communicated further. And the routing being followed in this kind of network is data-centric. Let me explain what I mean by data-centric routing. In a normal computer networks, what we do is data is a payload which is part of a packet, and we have a header specifically for routing purpose. Not only the header the packet has, even a routing protocol runs on top of this separately to cater for routing the packets, okay, or identifying a shortest path, all those things. But here what happens is we do not have such flexibility or ability to do that, so we use data-centric routing. I will tell you what it means. Here, each nodes are not uniquely identified. They don't have a specific address that a sink knows. I know the node A, which is here, and I need to communicate it using some particular address. So it doesn't have such a facility in WSN. Now, how do they communicate? Based on the collected data from multiple responding sensors, the querying unit, usually called a sink, identifies the sensor. So I already explained this in one of the earlier discussion. If you can think, I in fact gave you a similar scenario which is using this kind of a communication. Okay, if you remember UWB, and then we discussed about locating a key in a particular domain, and we have a mobile which is there, and then we said that there are some fixed network or sensors which are there to localize the key as well as localize the mobile so that we can guide it towards the key which is lost. So that is a good example of WSN. We have a known locations. Some sensors have known locations, and most of the other nodes in this are unknown. And using these known locations, we are trying to localize this area. Okay, we are trying to find out where exactly the key is, and then we guide the mobile towards that so that we can achieve the application requirement. So similar to that, this is one good example of a data-centric approach wherein we we get the information about the positions of this other nodes and then try to find out the location of this node. Whereas any of these devices do not know exactly, they don't have a unique ID associated with them. Okay, maybe we will identify that it is from coming from mobile or coming from a key, but there is nothing specific addressed to that particular node in the device, in the network. So it's a data-centric routing. The query, what happens is the sink. I said that sink is the one which is collecting information from different nodes. They query the nodes. Okay, they send a query to each of the nodes and then collect information from them and then try to find out the location. Okay, based on the nearby known sensors, if it is required. Otherwise, in this application, what I mentioned to you, we need to know the location of the key. Whereas in a agricultural field, we may not be interested in knowing a particular sensor in a field. We want to know the collective information about the humidity or the water content of the soil. So we don't need to worry about a particular location. So it depends on the application finally. So the query is not normally addressed to any specific sensor, but it is based on the data observed from the sensor, which is called data-centric approach. Moreover, as nodes in a locality sense the same phenomena. Now, one more thing you should remember, in a given area, all the sensors, if they are measuring the humidity or the soil manure level or whatever, phosphate level, they will all be measuring the same, more or less the same data. Okay, not much of difference will be there between them. Now, we cannot communicate every data that we collect and then send it across. It will be too much of data that needs to be communicated over network. So what is done is, there are some techniques done to fuse this data, aggregate this data, so that we only send what is needed across, because most of them are looking same. So maybe in the data science course you might have studied about it. So what is happening is, we don't follow a end-to-end routing here in this communication network. We follow a data-centric routing suited for here to perform operations such as data aggregation in sensor network. So we want to do some data aggregation, and we are not bothered about a particular location of any node. So we don't do an end-to-end communication here. We follow some data-centric routing. Okay, what happens is, suppose as a node is receiving data from the nearby thing, and suppose D1 is the data node coming here, and then this is also generating some data which happens to be D1, then this node can decide whether to send both or one of them, because if they look same, they may fuse these two and then send only one. So we can have a data-centric routing wherein amount of data which is communicated is brought down by doing data fusion or data aggregation, so that the low power network can still sustain and can live longer without burning up the power to communicate. So this is all very important. The data-centric routing is not only based on the data that we are collecting is not very different. We need this kind of routing. Even the environment in which they live, because of low power devices, they need to be very choosy about what to communicate over the network. And if it is required only, it will send, otherwise it will not. So what they do is, normally, because there is no unique ID, there is no routing protocol in specifically running there, we do a network flooding. Every node communicates to the nearby node, but all the data is not communicated and they get filtered out, so that we still save some power in communicating the data across the network. Now, that's what I mentioned. Data aggregation is another characteristics of this WSN. Now, this is a good example of all the nodes communicating to sink, and then sink communicating back to the controller. Now, what happens is, if a node A shares some information, as I said, it is a flooding. That means every node needs to communicate all the data that it receives from nearby nodes, as well as its own data. It needs to communicate with all the neighbors. If it does, the same data which is coming through different path will reach D. Okay, so it's a duplication of data, which is called data implosion. Okay, this phenomena is called data implosion, similar to explosion. In a typical data explosion, exponential explosion means more data is generated over time, whereas in data implosion, the same data coming multiple times, redundant data appearing again and again, is a phenomenon called data implosion. And WSN has that feature. I mean, that's not a feature, it's a problem with the WSN environment. So it has to handle it. So the protocol that we are running on WSN needs to take care of data implosion. So energy is therefore wasted. If the same data is communicated over and over, it's a wastage of energy. So it is desirable to process such a data, so much of data locally, as far as possible, process it locally, and then transmit only when it is required. So if it is a duplicate data, it will be suppressed. That is called data suppression. Now we don't have to pass it across. Eliminate the duplicates. Even your own data is same as what is coming from the nearby nodes. It will only communicate one of them. It will not communicate both. And as I told you, the sink is not bothered about the location of the data, where is it coming from, because in this kind of scenario, if a similar data is there, it will get the maybe an overview, because we are trying to understand the global view of a given area. So data suppression is allowed, and it is to be done in this kind of a network. Data fusion is, suppression is a redundant data. Data fusion is a similar data, which suppose there is a difference of very sigma level, then we can fuse the data and then give one single data. So that also can be done. But all the techniques, whatever we use, they need to have low power. They need to take care of the low power environment. They need to be efficient in terms of performing them. We cannot expect it to do a big arithmetic or processing to do that, because these nodes are very low end devices. So this is one technique which is a characteristic of WSN. And localized algorithm. So this is something similar to what I explained about UWB and then localization of data. Localization is a process of computing the location of wireless devices, especially in the absence of unique ID, identifying the individual node. Suppose if you are required to identify the individual node, then the localized algorithms are performed. Moreover, in some environment, even the delay and communication overhead associated with the global information, we can affect the overall performance and reliability. So what happens is, when you have such a global, if you want to collect the global information and collection of and dissemination of such information, we need to also take care of the reliability of the data that we are sending across. So we need to bother about the delay and communication overhead associated with that. So localization algorithm takes care of the delays as well as the communication overhead. It brings down, because you are getting to suppress the data, as well as if you are extracting the information from the available data that you have. So what is happening is, distance estimation is done. UWB is a good example. Position computation is done by the devices, and a localization algorithm is run to identify the location of the particular node which is sharing the information. So this is one characteristics of WSN. There are unknown nodes and reference nodes, as I mentioned, for locating a particular key in an environment where we have nodes which are kept in a known locations, which are called reference nodes. We can deduce the location based on this algorithm. So this much understanding is enough for you to know that this can be run on WSN based on the application requirement. Normally they are done in distributed manner, not a one particular node is doing it, because you can imagine, you can understand why it is required, because any node in an environment can fail, because it is living in a either hostile environment, or because of power availability, they may drop off, or they may not be reachable because of the communication is not proper. So it should not be in a single area. The localization algorithm needs to be run on a distributed manner, so that even if one node fails, you can still achieve what we want. Okay, that's the reason why we have such a requirement in this kind of a network. Local processing and collaboration among sensor nodes are also encouraged for filtering and combining readings from sensor nodes in a neighborhood. So these nodes talk to each other and they work as a team to take care of the difficulties the node has, or not only node, even the environment has. I hope you understand the need for this characteristics of a WSN. So let me just ping you once. Where are you? Who are all there? Okay, no questions. Mostly I will be completing all the generic IoT fundas with this lecture. So unless you need me to cover something else. Okay, now I didn't see the time. Okay, now let us understand two popular architecture used in WSN. One is hierarchical architecture, wherein we have cluster of devices and there is a head, cluster head for each of the clusters. So cluster is also formed ad hoc manner. Okay, it is not that somebody configures these clusters based on the distance between the nodes, because they are all mostly radio communication. So they can sense the distance between the nearby nodes. Let me tell you, because radio communication is happening and they communicate among themselves what is the strength of the signal they are transcending. Okay, they decide about the strength of the signal what they radiate based on the distance between them, and they sense the distance between them based on the timing characteristics, even though there is no time clock synchronization which is possible between the nodes, because we cannot have an accurate clock synchronization protocol running between the nodes. But still, based on the radio strength, radio signal strength, they can deduce what is the distance between the nodes. Okay, and then they find out how much power is required. So they don't communicate or radiate more power than what is needed. If suppose all the devices are nearby, they don't transmit more. That means they avoid that whatever being transmitted by this sensor node disturbing with the other clusters. So we avoid interference between the clusters. At the same time, we save power in each of the nodes, and we also do the communication in an efficient way because of this kind of a minor corrections or optimizations done in terms of transmitting power and from each node. Okay, these are all some RF techniques used to save power on each devices, which is being done in our mobiles also, even our Bluetooth devices also. This kind of optimization is done. See, suppose your mobile device is very close to the tower, they don't radiate very high power to the tower. Okay, because they find out the distance between the BTS and the mobile, and they radiate only what is needed. So that kind of optimization is done by the radio compiler. So our battery is saved because of that. So this kind of optimization is naturally done in WSN. And hierarchical system, clusters are created to perform data aggregation. So what is the purpose of data aggregation? Once these devices are nearby, we know that the data which is being sent by these sensors may not be differing from each other too much. So we can do a data aggregation. One of the data fusion or maybe data suppression can be performed, and then the communication between the cluster head and the other hierarchical node, it can be reduced. This communication can be reduced. If you reduce this communication, this device can radiate only for a short duration, saving power. So even that communication needs to be preserved. Power has to be preserved. So node in each cluster is designated as cluster head, one node. Okay, and that also will be configurable. Suppose this node fails, somebody else may take the control of becoming a cluster head based on the protocol. Traffic between nodes of different clusters must always be routed through the cluster head. So each node will not communicate with others. So it is not same as flooding. Okay, flooding does not happen between the cluster. It will be happening within the. It may not be even flooding, because once you identify the cluster head, then maybe other devices will communicate directly with them. So it is locally identified. Okay, though they don't have a unique ID at the global level, they are visible within the local area. Okay, they have a unique understanding. Okay, one node is different from other nodes, so that is understandable within the local domain, but may not be at the global level. So they are maintained for CH, the cluster head are maintained is maintaining the connectivity among neighbors, and clusters are formed in a distributed way. It is desirable so that global knowledge of each location of each node is not required. So that's what I mentioned. So they are in a local area, so the clusters are formed. So we don't need to know the global picture. So it is all known at the local area. So the clusters are formed and maintained based on the local information. Nobody is controlling from the top that this is what is going to be your cluster. Similar to our LAN, based on the physical location of the devices or the department, we do VLAN or LAN, we configure it. But that kind of a configuration is not performed here. They are all done in a ad hoc manner. That's why it's called ad hoc computing or ad hoc communication. So CH in each cluster periodically collects data from the neighbor and aggregates it and sends it to the top level. So this is how a hierarchical system works. So communication is localized and the data aggregation happens here, and then they communicate back to the higher level, and then this there may be multiple layers here. This now I'm only showing you 2 layers. And if you want to read more about this, there is a nice paper written. You can read about it. Okay. Now, what is flat architecture? It's another way of, based on the requirement, one of them may be followed. In a flat architecture, there is nothing called any identified node for a communication. It is, so we need to have a flooding here. And of what is happening here, let me explain. All nodes here are equal, and connections are set up between the nodes that are within each other's radio range. So what is shown here is the radio range. The dotted lines are the radio ranges of each devices. What they can reach, how far they can reach. So based on the radio range, the clusters are formed, or not even clusters, they communicate. Okay, they do flooding. And although constrained by connectivity conditions and available resources, of course, even though you have a range, not all the nodes may be in a visible range. Maybe some may be in a shadow range, or some may be having a low power, that even some may be dead. So we have not that all devices will be communicating with each other in a range, but whoever is there in the range, they will be able to communicate. Now we need to find a route so that finally any device here will be able to reach the sink. Okay, the aim is to inform what is being sensed by each of the nodes to communicate to the sink. Now that could be done in multiple ways, because each node is not always radiating or communicating. They may do different ways of communicating between the nearby nodes, thereby reaching the sink node. Okay, they always communicate with the nearby nodes, but they finally reach the sink node. The data reaches, but communication cannot happen between these two directly because the range itself is limited. So they only communicate with the nodes which are nearby. Now somehow the data has to reach, but all the nodes need not be always active. Remember, they are all constrained nodes, so they may be sleeping for most of the time and waking up sometime. So what happens is, based on the availability of the nodes, or maybe they may have a sync up between them, that I wake up in a particular time, that sufficient number of nodes are available that they can communicate through them. Okay, so some mechanism has to be derived at to somehow pass on the data to the sink. So the route discovery are carried out in flat networks using reactive flooding. Reactive flooding means all the nodes do not just radiate or send packets around. They react to queries coming from the other nodes or from the sink. Sink may be querying it, or it may land into each node. So based on the query, they share the information. So thereby you save the power. You don't flood always. You don't periodically send information across. So during flooding, each node broadcasts the data packets till all the nodes in the network receive the packet, which results in implosion. Now suppose if you keep flooding, what happens is it results in implosion, data implosion, which I explained. So the protocol takes care of handling that using directed diffusion. So it sends the data only in a particular direction only to a particular node which is querying that information. So even though you have so many data, so many nodes in the range, only which is receiving or forwarding the query, they may be informing or receiving the data from the node, each node. So query based protocol, where query is flooded in the network by the sink, which establishes multiple routes between the sink and source. So it queries the nodes and then it gets flooded into the network, and then they communicate back. Now there may be some shortest path routing protocol which may be used to for this node to communicate to this sink. There are different ways of doing it. Another thing is gossiping. It's another technique which is used in a WSN network, wherein the nodes communicate the data not to everyone but randomly choosing the nearby neighbors. Neighbors is nothing other than nearby nodes. So they randomly choose nearby nodes and then forward the packet, not to everyone. By not sharing the data to everyone, you are protecting the power of your own device as well as the receiving device also. So because once a packet is received, it needs to be processed, so it consumes power. So if you don't send it to everyone, then it saves power for the receiving node also. So gossiping is randomly communicating information to the nearby nodes, not to all but few of them. So these are the different architecture or different methods used by flat architecture to communicate the information to the sink, thereby the data gets communicated further down. I hope this is clear. Now this is the last information about WSN. I am not going to spend more time. Intrusion detection, as I mentioned, if we can put the sensors across the borders, especially the border which is sensitive, and then we can sense intruders coming into the area. Traffic monitoring on roadways. So this will be useful for traffic management as well as emergency handling or any untoward incidents happening. For that, we can keep sensors. Always the sensors need not be only the cameras. Okay, traffic can be also sensed by normally what happens in places where traffic signals have to be put. You have to make it green or red based on how many vehicles are coming in each direction. There are some infrared sensors are put across the road to find out how many vehicles are crossing, and based on that they find out the traffic or a density of cars in a particular lane or a particular road, and then they maybe keep the green signal for a longer duration, or they adjust the time so that this traffic will pass through without much of a delay here. Similarly, if there are no traffic in one road, maybe it will be red for a longer duration and these vehicles can pass by. So we can control traffic based on a simple sensors like this, and then communicating it back to a control center where different traffic signals are controlled in a city. So I have observed it in the US. This kind of things happen because normally in some of the roads, in our roads, we can see that we get a green signal and then we come here and stop in the next signal because there will be a red there. If suppose all of them are aligned, we could have easily crossed by the whole thing. But because of this lack of this particular system in place, they are not in sync. The traffic signals are not in sync, and they actually lead to congestion and traffic in a typical roads like Bangalore. And this kind of nodes network can be used in industrial environment where you want to sense maybe smoke in a particular area or a temperature or any gas leak in a industry. There are different sensors can be there which can avoid a lot of fire hazards that are happening in the industry with this kind of a network. So heat and control of we can do it, heat control or conditioning for a precise temperature control in an industry area or even domestic home environment, or we can do it in food industries also, wherein you want to know the exact temperature of different materials are being used in the industry. Okay, we can control many things using them. And a building and bridges can be monitored, and there are systems there in bridges, long bridges, wherein any they need a maintenance. Okay, a lot of hanging bridges which are there, they need regular maintenance, and these sensors in the network give you this different stress and strain um, sensed by different ropes or the structure in the bridges. They can be sensed, and then based on that maintenance can be planned, and then people will be sent across to maybe tighten something, or to maybe corrosion, or if there's a lot of rain, then corrosion can be done or painting can be done. So a lot of maintenance jobs can be done with the WSN being there in the huge network or a road or a bridge. We can monitor it, and maybe even some bridges failing can be predicted, and we can avoid traffic over the bridges if it is in a very dangerous situation. So even earthquake can be predicted, and traffic can be stopped going across the river bridges. That can be also be done. So I am sharing different scenarios where these devices can be used, so that you can come up with new use cases for your own projects, or even you can patent some of the things. Now if you come across some innovative ideas, because a small idea like this only can spark off some good innovation. So understand where these things are used, and where such devices can be used potentially, maybe in a new environment. You can think of something. Even if your village or your cities have some difficult problems, you can solve it using WSN. So always be open to find out how do you solve issues that you see in the area. Okay, whether can we use IoT there, please always keep thinking about it. All these ideas may give you some good use cases which nobody has tried it out. So environmental monitoring can be done, and forewarning of natural disasters, which very recently happened, or Chernobyl kind of a nuclear explosions can be predicted, or not predicted at least, but at least monitored and controlled. And even if you want to take care of chemical sensing, if you have a chemical sensing capabilities, you can even sense the chemicals released by the industries into the river, and we can give alert to the people there, so that we can avoid illegally people releasing the chemical into the river, so which happens in Ganges or even major rivers in India. We could avoid all those things. And wildfire, which is very popular and is happening in California in the US, as well as in Australia, was in wildfire for quite some time. All that could be avoided if we have sensors all throughout the area, because deploying such sensors are cheap, and we can really avoid such calamities happening in even wildfires, like environment. So these kind of things can be used. Now WSN can be used in many areas. There are potentially innumerable use cases for deploying our IoT solutions, and I want you, each one of you, to think about different ways of using them, and come up with ideas. Try to patent things. I'm sure you will be able to get some innovative thoughts on this. Okay, so that's all I have. Unless you have any questions, we can address them. Commercial CCTV cameras like okay, can you give me a scenario?
Yes, sir. Actually, there are some commercial cameras, and if we want to put a camera on CCTV, like traffic controlling, as you mentioned earlier, so we can connect the Arduino or Raspberry Pi with that camera, and the train data is used to use with them or not.
Okay. See, what you are saying is about the images that we are getting. So let me try to understand your scenario. What you are saying is you have a traffic camera. Either Okay, camera.
Yes,
Let
sir.
me.
Yes, sir. Most of the places they are already camera installed, and if we want to apply our AI technology or some methods, it is possible to apply those changes on existing cameras, or we need to set up a new camera or new special type of camera which support AI technology.
Okay. First of all, let me tell you. Okay, I understood where camera. Let me. I think it is. Oh, it looks like a camera. Okay. So the main thing is camera sensors. What we need to know about is the pixel. Okay, what is the amount of clarity that you get from these cameras, and then whether they are digital or analog cameras. Now, what format you get it. Okay, so right now whatever cameras we have, they're all kind of only sensors. They don't have any intelligence. We can't call them as a sensor node. So what you are asking is, can I make a sensor and then attach some intelligence like RPI, Raspberry Pi, and then make it a sensor node? Okay, so it is possible, provided we know what is the output coming from the sensor camera what you have. In case if they are all analog cameras, and then they only can be connected through a coaxial cable, and then send it across to the control room where they can, live feed can be there, then they will be monitoring it, okay, in a traffic control room. If that is not the case, if you have a digital camera already is a place, and then it is giving you the data in that format, then we can just easily interface it with the RPI, or if you have a proper interface, camera interface, if that is compatible, the whatever cameras you have, then we can perform it. Otherwise, we need to change the whole setup. Okay, it's not just you can upgrade the existing system very easily. It depends on what is there. And second thing is, power may not be a big issue, because if you are normally installing the system where the traffic lights are there, so there are traffic controller, they have access to the power, and they can always put some DC power source, so that they can supply the controller. Traffic lights are also controlled by some microcontrollers nowadays, because mostly you can see that they program it based on the time and then based on the traffic, but they don't use the live traffic data, but they are intelligent enough to at least adjust the delay between the different junctions based on the time. So police, traffic constable adjusted it. So we can do it, provided you have a camera which is compatible enough. Otherwise, you may have to redo the whole thing to add AI capabilities. So now, what all you can do? You can think of AI capability like, if I feed a particular license plate number, okay, license plate number, can I identify the different cars are coming into the going in the road? Can I locate a particular number of interest? Okay, suppose if somebody is on a run in a car, and the registered number, license plate number, can I immediately instruct all the traffic signal cameras with a AI built in, and if I feed a traffic information data saying that identify a particular registration number, then it should be able to alert the nearby police or a station or a red signal, or even it can even trigger a red lamp, so that that car cannot pass through, or down the line they can control the traffic. They can put a red light on all the places, so that the car with that particular plate number cannot go further, and it will be blocked. So these kind of things can be implemented. Okay, if you there are already system, but you can do it. Okay, I hope I answered your question. In case,
Yes, sir.
so think of these things. Even if there are some systems like this already, don't worry about it. Doing it yourself or doing it ourselves will be a good example. Try to think of how do I build a AI model, train it for identifying different number, plate numbers, or even a prototype can be built. No, not actually a real camera which is at a longer distance to identify a car, but you can still build a prototype, and then you can maybe productize it later. we have lots of potential in IoT to come up with new products. And I am sure many of you will be already thinking about how do I start, my own company. And this is the area where, if you read and learn more about the technology and the environment domain of IoT, I'm sure you will be in a position to come up with new products yourself. So that's the intent of me sharing knowledge of what all is there in it, and then you can go deeper into any one of them based on what you want. Okay.